Hello, CS4740. This is Neil McGee. So I'm putting together a little YouTube playlist for you here of a few videos, including this one, for in place of a lecture for next Tuesday, which is Thanksgiving week. Our subject is machine learning and artificial intelligence, and there are just so many offerings in the three big cloud providers that we've been talking about all semester long. I'm not possibly going to try to recap all those or categorize them all or index them for you or anything like that. I kind of just want to put a few videos in front of you that can do a better job than I can about a couple of those services. Some very serious, some just kind of fun and interesting, along with this video, which I want to just kind of touch on a couple of things myself. So first thing is, if you dive into the AWS console and you open up the All Services tab here, you're going to see a monstrous pile of machine learning services. This is ML and AI all together. And I think the first thing I'd say about all of these is that they fall into two levels, really. One is the low-level sort of hands-on service that lets you adjust and manipulate everything. So a service like SageMaker is just a raw machine learning service. Lets you train models, lets you set up automatic training and so on. Then you can use those models, you can store them, deploy them into other services and so on. So it's very, very granular, very low level, and gives you a lot of control while at the same time kind of creates resources for you behind the scenes that you don't have to build things manually. You don't have to install TensorFlow or, all these different packages to support your machine learning. It's kind of ready to use, and it kind of lets you do the raw stuff yourself. So that's the low level. The higher level is more of the service level, which has these pre-trained, pre-prepared machine learning AI services ready to go. So something like a Polly and a Lex, they go together. Polly is text-to-speech, and Lex is speech-to-text. They work together to create the Amazon Echo Alexa service, among many other things. You can do lots of other things with them. But, there's no real training to do there. There's no instance to turn on. You would have to use it so many millions of times to even, get a decent bill for the month, because they're just kind of the shiny, cool things that just work right out of the box. You can just consume them. So I want to show you a little example of that. But you'll see a pretty large, population of services just here in AWS. A few I might point out. One is called Forecast, which is it's a time managed time series forecasting service. So you can sort of look at things that have accrued over time and then forecast things for you. Translate is pretty obvious. Rekognition, I'll give you a demo in a minute that deals with images and video. Deep Lens and Deep Eraser are pretty cool. Deep Lens ties into SageMaker, and I'll show you a little bit about that. And then Deep Eraser is a contest that is held every year at AWS reInvent in Las Vegas. They also do regional contests as well. I'll explain those later in slides. But as you can see, some of these are pretty tricked out and already, kind of advanced, again, pre-trained services ready to consume. Others of them are kind of light at the lower level. So what I'd like to do is show you a demo of Rekognition and how you interact with it programmatically in the command line and in Python, but also what you're going to get back and kind of what you're looking for when you consume these services. So hang on a second, let's flip over. So flipping over to Rekognition, Amazon Rekognition is an image and video analysis detection service. This is one of these higher level, pre-trained, kind of ready to go services that you can just consume. And it's pretty interesting. There's several angles, several methods that you can apply to images and videos. And I just wanted to show you a little bit about that and how you interact with it. It tends that you're going to either push an image in binary that you base64 encode. You're going to either push that to the API, or you're going to reference things that are in S3. So you can't just take a URL from the internet and pass it to Rekognition. That doesn't work. You need to kind of pull it into the Amazon ecosystem. But it has a few modes. So first of all, there's label detection. So this means, hey, Rekognition, here's an image. Tell me what you see in here. Label, all the labels that you detect. Image moderation, it could detect nudity, violence, firearms, blood, and so on. So when you see some moderation warnings on a video or image, this would be something that could automatically detect that for you. Facial analysis, so it's going to tell you what it sees. Glasses, a smile, a frown, a hat, and so on. Celebrity recognition is always fun. It's always fun to play with like B-list celebrities and see if it can actually recognize them or not. Face comparison. This is where you can give it a reference photograph, a reference image, and then a new one to compare it to, and it will tell you what sort of matching it sees between the two. You could imagine kind of a silly scenario of this, maybe where you have a Raspberry Pi at a door and somebody has to press a button and it takes an image of them and then it compares that image against, a library of 20 other images from people from your team. And it's like, oh, Neil, I recognize you. Here, I'll let you through the door or I'll give you a bonus for the week or something like that. I've actually heard of police forces and, the FBI using this with known criminals, so they can take a booking photograph and then compare it with other photographs that they have of people. Legally, I'm not sure how I feel about that exactly, but that's what a service like this is capable of doing, is looking for those matches between. Then you can look for text and PPE and so on. Just to show you a little bit about the so let's just say label detection. If you go to their kind of pre-built demo here, you can see it takes this image and it just draws as these algorithms do. They just a lot of bounding boxes around things. It's like, hey, that's a thing I should know. I should know this. So it recognizes cars, it recognizes a person, a skateboard, and so on. And you can kind of unfold all the results and see it sees that it's in a city, it's downtown, there's wheels involved, there's sports involved somehow. I don't see a pedestrian, but it sees that somehow. And it gives you a confidence rating with each of these. So that's interesting. Rekognition does have a capability for you to upload a stack of reference images, and you can manually tag them and label them and basically train your own model against which you can then run. It's like you're helping inform Rekognition of things to recognize in your images. Now, my understanding of that, and I'm not 100% on this yet, but my understanding of that is that if you train images that you've uploaded, that those aren't then kind of going into the greater pool of Rekognition training that other people would then be able to consume. I believe it keeps it to your account, but I should check on that and get back to you and see. I mean, that's a kind of a new aspect to this service that I haven't worked with before. So I'd like to know more about that. So I actually have something here. I have a coffee maker, a Cuisinart digital coffee maker. It's pretty. I just pulled this off Google Images. It's pretty up close and cropped. It gives no context of like a kitchen or anything like that. It's just sort of a product image. And what I'd like to do is flip over to Visual Studio and show you how we interact with this programmatically. And it's pretty simple. This is in command line. So I'm just going to use AWS Rekognition detect labels. And then the only parameter I have to give it is an image, and that's a JSON payload of an S3 object, and it just follows this format. You could send it bytes of an image, or you can send it something in S3. So I have an S3 object, and then I give it a bucket and a name, and I'm not using versioning, so I don't have to do that. So this is pretty simple. Bucket, name, which is the key over here. So if I clear this, and I'll just run this detect labels, then what you see I get back is something actually not all that helpful. So it can see that it's an appliance, and it has a 95% confidence there. It thinks it might be a mixer, and it's 89% confident about that. It sort of shows me the bounding boxes and so on. So yeah, it comes up basically in the end just thinking, yeah, this is an appliance. And that's sort of the parent category. And yeah, that's correct, but that's not very precise. So let's fold that back down. Let's show you a detect faces command. So in this case, I'm going to use, and I'll show you the image. I'm going to use Tom Hanks. So here we have Tom Hanks with his funny kind of wry smile there, his squinty eyes, his hair's back, and he's in a tux. So I have that in S3, and now I'm going to use the detect faces command, and I'm going to ask for all attributes back. And this is kind of an interesting response, because actually it's not going to tell me that it's Tom Hanks. Let me clear this. I want to detect, faces. It's going to give me something different back. So face details, it describes the bounding box on the face. It gives me an age range. I'm actually not sure. I guess Tom Hanks falls in that age range. Yeah, I believe so. And then it gives me these other attributes that it's looking for in faces, whether they're true or false and what sort of confidence that value is. So does he have a smile? True, 98% confident of that. Is he wearing eyeglasses? False, 99% confident of that. No sunglasses. He's male, appears male, has no beard, eyes open, mouth open, and so on. And then it looks for these emotions: happy, disgusted, fear, sad, and so on. And then it tells me if there's any landmarks around, by which it means the typical AI sort of mechanics of measuring a face from the eyes and the nose and the mouth. It's even got brows, brow up, brow down, and so on. And then it gives me this pose of roll, pitch, and yaw, sort of like an airplane positioning for how the person is standing, how they're seen, and then the quality of the image. So that's a lot of information about this one image that I just submitted that could be useful. It may be completely superfluous, and maybe you don't want all the attributes. You could request certain regions of that data instead of all of it, but I wanted to show you it's possible. Then we have this recognize celebrities command, and now I'm going to use the same Tom Hanks image to just say recognize celebrities. And this gets pretty interesting as well. Recognize celebrities. And notice right away in the response payload, it references some external URLs, and this is where it's been trained. So from Wikidata, it's got an image. From the Internet Movie Database, it's got a reference. It says it's Tom Hanks, and it has a 99.9987% confidence in that. And when we ask it, when we want to know, hey, how are you confident of that? It gives me the basic geometry of the face. This is how it knows. Eyes, mouth left and right, and the nose, and so on. And then again, it gives me the pose, gives me the quality, and the match confidence. However, I could take another image of Tom Hanks, and here's another one I found, looking wistful, looking like he's staring off into the distance, thinking things. So now he's got glasses on, he's got a beard, but I can tell that's Tom Hanks. So that's called Tom Hanks side, and I also have that in S3. So I'm going to run that one so we can see what we get here. Clear, recognize celebrities this time, and it gives me an unrecognized face. And I could drag this into the GUI and get just the same results. It doesn't recognize that as Tom Hanks, and that's just a limitation of the training. So I do that on purpose just to show you, hey, this is a pre-trained, pre-packaged model with its own library to it. Nothing I did about interacting with this image just now via their API, nothing that I did informed them that this is Tom Hanks. So it's not like it's learning from me. It doesn't know that it missed, it knows that it didn't recognize it, but it doesn't know the correct answer to who it was. So in a way, there's no feedback here. There's no loop in which I as a customer, I'm going to kind of help improve the quality of this training. So that's a bit of an issue. But again, now that they have their own training available, if I really needed to train that image, I suppose I could do it for my own needs. Now, because we're in artificial intelligence this week as a subject, I did want to show you something interesting. And I've mentioned this in class before. I've started an empty stub of a Python file, and I've copied in the S3 URL and the recognition. I'm actually going to uncomment these things so that they're visible to the code. I'll uncomment them in a moment. But I'm using Visual Studio right now with the GitHub Autopilot. And Autopilot is an artificial intelligence programming tool. And this is just pretty interesting. I want to see if we can make this work right before your very eyes. Bear with me for fixing any little errors and bugs here. But let's say I stub it out to see Python in my environment. I import Boto 3, and I just say, definition, recognize celebrities. Well, there we have it. We already have a stub that it's reading from the documentation in Boto 3 that if I'd like to recognize a celebrity, I can just hit tab and I have it. Now I could also and I don't want that. I don't want triple curly braces here, but it's now finished my payload. So notice this. I just started typing recognize celebrities, and it's kind of seeing things from above a little bit, I think, although I could try this without, and maybe it would just do it anyway. But it knows I imported Boto 3, so it knows something about recognizing celebrities. Notice that it created a client for me. It created a response with the exact right method. It knew already that it requires one thing, which is the image parameter. And now I could just basically say, print response. And then down at the bottom, I can just say, recognize celebrities. Oh, look, it recognized that, my bucket and my file name from the lines above. So now I could take this, comment it out, save the file, and I should be able to just issue this in Python and get exactly the same things back. So let's clear that, recognize celebrities.py. There I have it. This is all the same as before. Celebrity faces. It knows that it's Tom Hanks because I used the first image, face boundaries, and so on. So yeah, so here's AI in programming. So I've been using this about a month. I'm in the beta testers for Copilot. And I have to say, I've been using Chalice to show you guys some demos. I've been using Boto 3 for my normal work stuff. And this thing, for basic functions where I just need like a fleshed out full function that knows all the parameters and variables already and can see what I've been doing so far in the code, I'd have to give this a pretty big thumbs up. It's saving me time already. Maybe I should be fearful that it'll take my job someday, but in the meantime, I'll just kind of enjoy it. But yeah, so this is auto-sensing what I'm up to within my code. It's also seeing the libraries I've imported, so it kind of has an understanding of the realm of what I might want to do. I'm going to flip back over to the recognition console and maybe just back to the AI services in general. Because what I want to show you now, what I'm going to include in this playlist, is now an in-depth a demo from an AWS solution architect on SageMaker, which is just a good low-level, good to have in your toolbox sort of understanding of how to work with that. And then I'll attach a Deep Racer and a Deep Lens video as well. So Deep Lens is actually a camera, and I own one. I was given one at reInvent for doing something. I don't know. I filled out a survey or I entered a contest or something as an educational provider, and they sent me a Deep Lens camera. It's a digital camera. It comes, it's pretty small, pretty compact. And this thing works automatically with SageMaker. So it knows how to go ahead and work with the models that you create so that basically this camera could be operating. You could have it on remotely someplace, and it will be recognizing things that you have trained it to recognize automatically. So the video I'm including is pretty funny from this guy about his cat. However, it's a pretty compelling proof of concept just to show this thing is capable of some fairly serious recognition. And then finally, Deep Racer is so it's a contest that Amazon runs with a car. I don't know if the car is a kit or if you just buy the car. So it's a model car. I think it's 1/18th scale or 1/8th scale or something like that. That runs on a pre-formatted track. And the track you can get all the dimensions and specs of this track exactly. And the track apparently never changes, or maybe they change it once a year and everybody knows. And the point is to program your Deep Racer to race this track as fast as possible. And so it's a timed event. And the track is gray, and everything off the track is green, and there's dashed lines down the middle of the track, and so on. And so teams from various universities and various companies actually get together and enter their submissions into the Deep Racer contest. There's always a winner declared each year. They always have the finals at reInvent at like the MGM Grand in Las Vegas while we're there for the conference. But it's another interesting use case. So I'll show you just a brief clip of the Deep Racer contest so you can get a sense for that. Those are all kind of fun and silly, but this is the holidays, so I'm going to give you some fun and silly sorts of things. If you are serious about machine learning and artificial intelligence, there are a lot of interesting ways you could go. And if you're interested, please send me a message because I could point you in a lot of different directions. One thing that you may be interested in is working on an Alexa skill. And that happens to use several ML, AI services and serverless services from Amazon. And basically, if you want to write an Alexa skill, you're going to think of the invocation for your skill, which is the sort of keyword that when you say Alexa, blah, 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 well, whatever that blah, blah, blah is your invoking word that turns on your particular skill. And then you're expecting some utterances from there. So Alexa, what's the weather, that would be your invocation, for 22903, my zip code. And so the invocation turns on my skill, and then the parameter is a zip code. And then it basically uses Lambda to very quickly go out and find some information, get that payload back, reformat it into text, throw it into Poly, which then sends it back to the Lex service to come through my Alexa. So this text is put into speech, and then Alexa is going to speak that back to me. So it's not an insanely difficult decision tree of what you need to do. But the interesting thing is that Alexa is really built on these pre-produced, pre-trained AI services to use speech and text and speech and so on. And then a whole bunch of APIs and Lambda functions and API gateways in the background to catch those requests, go off and do something smart with the request, and then bring something smart back to the table. So if I can find another good overview of that for you, I'll send that along in the channel as well. But anyway, I hope you have a great Thanksgiving. I hope you're safe, that you enjoy being with some friends and family and get a little break from school. And then when you come back, we are on the short road to getting done here, just about 3 classes after you get back. So I'll see you then. Thanks.